Hi, Art Kurtz here for Easy Access Math. And here's another lesson on simplify and add or subtract radicals or radical and regular number combinations. Before you could do this, you need to understand the simplify radical concept, and we have a video on that you may want to watch. But let's review that. It comes in this problem. Let's do the bottom one first. First, I'm going to simplify this radical. Now, the radical numbers go in line with your perfect squares, and we have a good video on our perfect square numbers. These are really important to remember, to become comfortable with. Now, when I have a perfect square, I could square root a perfect square, like 16. Square root of is 4. These numbers are perfect squares because when you square root, they come to a whole number. These are not perfect squares, but I could break them down. I could simplify them. Watch. 75 can be simplified as 3 times 25. You look at that list and you'll say, do I have a number on that perfect square list? And if you watch our perfect square video, I tell you how you can create a list on your scrap paper by multiplying numbers by themselves, and you get your perfect squares. 3 times 25 gives you the 75. The 25 is a perfect square. It comes out of the radical as 5. The 3 is not, so it stays in. Bring down my sign, and I'll do the same to the other side here. 48 is 3 times 16. 16. You look for the highest perfect square number that can go into that square rooted radical number. Radical of 48, the highest perfect square that goes into 48, 16. 16 times 3, and look what happens. The number that's not the perfect square, in this case the 3, match on both sides. If they don't match, you can't do subtraction or addition. You can only add or subtract the same radicals. If they're unlike radicals, you can't. But we made the radical part the same. The 16 comes out as its root, which is 4, and the radicals are the same. The 3's are the same. So now I just perform the operation. 5 minus 4 is 1. The radical 3 stays. And so I have 1 radical 3, which, we never write those ones. It would just be radical 3, the square root of 3. That would be your answer. Let's try the one on top, this green problem. Now I have a number on the outside. That changes things just a little bit. I do the same procedure, breaking down the 50 as 2 times 25. Keep that 3 outside, but I'm going to make room. And the 3 gets multiplied by this 5 that comes out. The 5 comes out because it's the perfect square of 25. The 2 doesn't have a perfect square, so it stays in. So I have 3 times 5 radical 2. And over here, I'm just going to draw this line so we don't look down here. It's just the top problem. Bring down my plus sign. And I'll do the same to this side. The 5 will wait for a while. Highest perfect square that goes into 128, 64. If I keep going down this list, 8 times 8, 64. 9 times 9, 81. You could keep making that list of perfect square numbers for yourself. Now what I'm left with is 64 times the 2, and look what happens. That 2 happens to match. That's going to allow me to add these two entities. The 64 comes out as its square root, which is 8. That's going to multiply by the 5 that was already out there. So watch. I'll multiply the 3 by the 5 that's outside on the first one. The 3 was out and the 5 came out. I multiply them to get 15. Multiply the number that you brought out as the root by the number that was already out there. So I get the 15. The radical 2 stays inside. Can't do anything with the radical part. I multiply the 5 that was out there from before by the 8 that I just brought out from the square root of 64, and that gives me 40 radical 2, giving me a final answer of 15 plus 40. Add them up, and I get 55 radical 2. And that's my answer, 55 radical 2. The radical 2 stays the same. So that was our second lesson, combining, simplifying, and adding or subtracting radicals.